The essential question for this video is, how do I use the properties of similar triangles to measure objects indirectly? By indirectly, it means we're going to measure them using the math properties of similarity. We're going to measure objects like, in this case, a flagpole, which are difficult to measure with a tape measure or with some other measuring tool. So we're going to use similarity for this. Let's take a look at the question. The sun creates a shadow of the flagpole on level ground. You measure the length of the shadow, and it is 24 feet long. Let's go ahead and mark that on the diagram. So from the flagpole to the end of the shadow is 24 feet long. Okay, let's go back to the question. You stand in the shadow and you move until your own shadow is exactly lined up with the top of the flagpole shadow. So you're going to stand inside the shadow. You're going to look at where the top of your head is on the ground on your shadow and make sure the top of your head is lined up exactly where the top of the flagpole is. Alright, now this sentence right here, class, is a typo right here. Will you please cross this one off? Actually, let me do this as a line. We're going to cross this one off. Somehow that got put in there accidentally. Okay. Last thing. If you are 6 feet tall and the length of your shadow is 8 feet, how tall is the flagpole? And it says drawing not to scale, so don't use the drawing to estimate. Use the values that we've given you in the question. So if you're 6 feet tall, let's go ahead and measure that. I'm going to go ahead and draw a line right through this little picture of a body. Okay, right through that body. And let's label that. That is 6 feet tall, or 6 feet from the ground to where my top of my head is. And then the length of the shadow made by the person is 8 feet. So that means the distance from here to here is 8 feet tall. So it's very important as you get these questions, you label the diagrams as you go. Alright, so now the question is, how tall is the flagpole? Well, let's find out if we can use the properties of similarity to solve this. The first things I want you to notice are, if the flagpole is built correctly, and we're going to assume that it is, then the angle that's made by the flagpole to the ground is 90 degrees. And if I stand straight up and down, I also can stand 90 degrees straight up and down from the ground. So we've got an angle here that's congruent. All we have to do is find another congruent angle, and we may be able to use the properties of similarity. Well, let's do this real quick. Let's label some of these points. I'm going to label the top part, kind of pretend that we've made a triangle right here with a shadow, and let's label the top of the flagpole A, and the bottom of the flagpole is B, and let's label the top of my head D. Let's label the, actually, kind of think about this. The reason I'm going this route is let's label the other point of the big triangle C. If you can see, there's a big triangle made right here, triangle ABC. And let's go ahead and label the top of my head D. And now where my feet hit the ground, let's label that as point E, right there where my feet hit the ground. So we've got, if you can see this, class, you have two triangles, a big triangle, ABC, and a small triangle, DEC. Now we've already established that we've got one angle that is congruent. Angle E is congruent to angle B. So this angle right here, angle E, is a 90-degree angle, and angle B is a 90-degree angle. So you've got two angles that are congruent. Now I want you to see, these two triangles actually have a shared angle as well. And that's right here. If you take a look at this, angle C is part of both triangles, ABC and DEC. That means we also have another angle that is congruent. Now I'm going to change something here real quick because I'm afraid these angle measures or angle labels might be a little confusing. So let's go ahead and write it this way instead. Here's our right angles. Angle ABC, there's this one right here. That is congruent to angle DEC. DEC. Those are both right angles. And I'm going to put on here in parentheses, they are right angles. Okay, and now we're sharing this angle C. That's part of both triangles. So I can say that angle ACB, that's this one right here, angle ACB, that one is also congruent to angle DCB. Sorry, DCE. Let's call it from the small triangle, DCE. Take a look, DCE, same angle. So those are the same angles, and the property that we're using here, class, is called the reflexive property. I'll just put REFL for reflexive. You learned this property last year in Integrated Math 1. Reflexive means that the two angles are the same angle, so they must be congruent to each other. All right, well, if we've got two triangles, if we've got triangle ABC and triangle DEC, and they've got two angles that are congruent, we know those triangles are similar. So we're going to go ahead and put our conclusion right here. That triangle, we can put so, and I'll put these words right here. If this is true and this is true, so triangle ABC is similar to triangle DEC. And notice that when I labeled the vertices, I made sure B and E were together because those are congruent, and I made sure C was in the same position, in position 3, because that angle is congruent. So that means our similarity statement is correct, and we know this by the AA theorem. So the first thing I wanted to establish with you is that when you do this shadow experiment to try to find the height of the flagpole, you've just created, by standing where you're standing, you just created two similar triangles. We can use those properties now to figure out the height of the flagpole. All right? So let's go ahead and write down here, if triangle ABC is similar to triangle DEC, then we can write our statement of proportionality. Let's go ahead and do that. Our first two letters are AB on our first triangle. They're DE on the second one. My second two positions in my first triangle are BC, and that goes together with EC. And then I've got my first and third position, AC, for my first triangle, go together with DC. Now remember, as we do a proportionality statement, remember, if I start off with this triangle ABC on top, that same triangle has to stay on top for every ratio, and the bottom triangle, DEC, the triangle DEC, that has to remain on the bottom of every ratio. So there's my statement of proportionality. All right, let's circle the measurements that we know. We know BC. We were given BC was 24 feet. And we know EC. And we know DE. Well, that works out really well because we're looking for AB. We want to know what the length of AB is. So let's set up our proportion and solve. So I'm going to write, my proportion is going to be BC over EC. Remember, you always start off with the ratio that you know, both the top and bottom. And that's going to be equal to AB over DE because the second ratio has to have the side length that I'm looking for, which is the flagpole height, which is AB. All right, let's plug in what we know. We know that BC is equal to 24. EC is equal to 8. AB is our unknown, that's what we're looking for, and DE is equal to my height, which is 6. Let's go ahead and cross multiply. 8 and x is 8x, and that's equal to 24 times 6. 24 times 6 is 144. Divide both sides by 8, and you get x equals 18. So we know all of our units of measure are feet, so that means we just figured out the flagpole is 18 feet tall. Let's go ahead and write that as a sentence answer. So I'll finish this up by saying the flagpole is 18 feet tall. So notice we were able to measure the height of the flagpole without ever leaving the ground and without using a tape measure on the flagpole. We did use a tape measure to measure the distance of our shadows or the height of our shadows, but we didn't have to actually measure the flagpole. We used the knowledge that the two triangles created were similar, and because we had similarity, we were able to figure out the missing side of the bigger triangle ABC, which happened to be the height of the flagpole. All right, let's take a look at one more. Here's another way to measure the height of this flagpole. So here's our story. You want to measure the height of a flagpole, so you place a mirror on the level ground and stand so that when you look in the mirror, right here, you look in the mirror, you see the top of the flagpole. If the distance from the mirror to the flagpole is 18 feet, so from the mirror to the flagpole, let's write that, 18 feet. The distance from your feet to the mirror ends up being 8 feet, and the distance from the ground to your eyes is 6 feet. Notice now, like the other one we were measuring from the top of our head, now we're measuring from our eyes because we have to look in the mirror, so that's the height we're using for this triangle, the height of our eyes, and that's 6 feet. How tall is the flagpole? Again, the drawing is not to scale. Well, before we can actually use these triangles to find the height of the flagpole, we have to prove that these two triangles are similar. Let's take a look, kind of the same thing we did before. The flagpole, if it's built straight up and down, makes a right angle. Let's go ahead and draw a line through my body to make another triangle. And let's say that we're standing straight up and down, which is really important, because we need to make a right angle to the ground. And let's go ahead and label our triangle points as well so we can call these out in our questions. Let's call this A, top of the flagpole, B is the bottom, C is where our mirror is at, D is where my eyes are at, and E is where I'm standing on the ground. Okay, so let's take a look at what we know. If angle ABC is congruent to angle DEC, again we can see those are right angles. So we've got one pair of congruent angles. How about another pair? This is the one that we may not know because this has to do with physics. But if you look in a mirror and then your vision reflects off that mirror, the two angles that the light traveling from your eyes to the mirror and up to the flagpole, the two angles on both sides of that mirror where you see the flagpole through the mirror, those angles are actually congruent. It's the same as what you're thinking about when you're playing the game pool or billiards. If you hit the ball and it banks off the edge of the billiard table, the angle that it's traveling when it hits the edge is the same angle that it travels away from the edge. So these two angles, we can mark these are congruent. And here's what I want you to do, class. I want you to write here, right above this, in this space right here, I want you to write law of reflection. Law of reflection, and then draw an arrow down to the mirror. So write the words law of reflection and then draw an arrow down to that mirror. That's how we know that these two angles from these two triangles have to be congruent. Now I'm going to go ahead and write this, and let's say angle AC, oops, I started writing B, and angle ACB is congruent to angle DCE. Those are these two angles. Here's ACB, so that's that angle. Here's DCE, that's that angle. These two angles are congruent, and we just talked about how that's the law of reflection. I'm just going to put LOR because if you've been paying attention on the video, you've already written the words law of reflection and put an arrow to that mirror. So we've got those two things. So triangle, let's label our letters. ABC must be similar to triangle. Let's match them up. A goes to D, B goes to E, and C goes to C because that's the same vertex, D, E, C. And that's because of, and I'll put on here, by a theorem. Sorry I'm cramming so much in a small space. I could have done this on the bottom, I guess. So now we've proven that these two triangles have two congruent angles, therefore they're similar, therefore we can use the properties of similarity to find the height of the flagpole. Alright, let's do what we did before. If triangle ABC is similar to triangle DEC, then we can write a statement of proportionality. Then we know that AB is corresponding to DE. Those are the first two positions. BC is corresponding to EC. And AB, the first and the third letters, correspond to DC. There's our statement of proportionality. Let's circle what we know. We know BC. We know CE, which is right here. And we know DE. So again, we know those three sides. And the good news is we're looking for AB, the height of the flagpole. Let's write our proportion, plug in the numbers that we know, and then solve for AB. So let's write our first proportion. Our first ratio is going to be BC over EC. That's the one I know, both the top and the bottom. And then we're going to pick AB over DE, because that's the one that has the missing side that we're trying to solve. Alright, let's plug in what we know. BC is equal to 18. EC is equal to 8. AB is our unknown. DE is equal to 6. Let's go ahead and cross multiply. 8 times 8. 8 times x is 8x. You've got 18 times 6. So 8x is equal to 18 times 6 is 108. We'll divide both sides by 8. Again, I'm going to show you that. Let's do it in the calculator. So we're going to divide 108 divided by 8. That gets rid of this coefficient, and that's equal to 13.5. So x is equal to 13.5. Since x is AB, there's the height of our flagpole. 13.5, and our unit of measure is feet, so 13.5 feet. So our final answer is going to be the flagpole is 13.5 feet tall. So again, you can see we can use the properties of similarity. We were able to create right triangles with a mirror on the ground. We measured three things that we easily could measure: the distance to the mirror, from the mirror to the flagpole, mirror to our feet, the height from our feet to our eyes. We stood in a certain place so we could see the top of the flagpole, and that created similar triangles where we could find the height of the flagpole.